Okay, so the last thing I want to cover here is how to actually, we've done how to find it graphically. Now we're finding inverses algebraically. All right, so these are our steps that we need to follow in order to do this. All right. Essentially, operationally, everything we see in the original set should switch out to an opposite set. All right. So if I look at the first one, I essentially see a minus 3x and a plus 1. So I see a positive 1. I'm probably going to see a negative 1. I see 3 times x, so probably division by 3. Okay. First step is change it to an equation value with y instead of f of x notation. So y equals 1 minus 3x. Switch the x values and the y values because that's basically setting your inverse up. So y becomes x and x becomes y. Okay, so this is essentially step 2. Step 3, solve. Okay, I personally prefer to always solve left to right, so I'm going to rewrite this equation. So this is my equation that I'm solving. And I'm solving for y. So y is what I want by itself. And so then I just need to do the algebra processes to do that. So subtracting 1 from both sides. Negative 3y equals x minus 1. Divide by negative 3 both sides. I end up with y equals, just going to put the negative out in front, I guess, x minus 1 over 3. Or I could write negative x plus 1 over 3. Generally, what I'm doing here on this last step, because I'm a picky math person, is I'm moving this negative somewhere that's more syntactically accurate. But if you left it right here, then that is, I would consider that a valid answer. Okay, so I'm going to use this answer as being more syntax right. Okay, last step is we've done the solving. The last step, though, is understanding that you have actually found an inverse set. So I'm changing y into the inverse statement. F inverse, remember that minus 1 just means inverse of x, equals negative x plus 1 over 3. And then essentially that is my final answer. Okay, so we're going to do a couple more of these. So the second one, f of x equals 4x squared minus 5. Step 1, change it from function notation to regular xy notation. Essentially, the only change is this becomes y. Everything else remains the same. Step 2, switch the x and the y variables. So y becomes x, and x becomes y. I don't change anything else in the equation. Step 3 is solve. And again, my preference is I like to solve left to right, so I'm going to sort this equation. So I'm just going to change the order. So 4y squared minus 5 equals x. Okay, that is my preference. You don't have to do that. I just like doing it. It just helps me to make sure I don't make mistakes. So plus 5 plus 5. Add the 5 first. Always working, solving is always working outside values to inside values. And when I say outside, I mean outside of the y set. So if this is my y set, I'm crossing this off. So I'm not looking at any of the y set. What is outside of that is the minus 5. So that should go first. Okay. So basically working from outer to inner. Inner means closer and closer to y. All right. When I'm stating that. So 4y squared equals x squared plus 5. Okay, again, outside to inside. So now I'm just going to say all right, that's my inside part, just the y squared. All right, what's outside of that is the 4. What's the operation that is happening with the 4? Since I see nothing in here, what does that mean? It means multiply. So that is divide. So now y squared equals x plus 5 over 4. And then to get rid of that square, I need to square root both sides. So final answer on this one. You can write y equals square root of x plus 5 over 4, or y equals square root of x plus 5 over 2. And essentially how I'm getting that last piece is if I'm considering that's the square root of x plus 5 over the square root of 4. Okay, please note that either you need to have the square root clearly showing it involves the entire thing, because you square root the entire side. You could even use some parentheses. Okay, or your square root needs to show that you're only on the top because you've applied it separately on the bottom. Okay, either one of those would be considered correct for this problem. So there you go. So last step then, f inverse of x equals, I'm just going to use the first one, square root of x plus 5 all over 4. And that would be my final answer as an inverse. So let's look at number 3. I'm going to sort of shortcut a little bit here. So I'm going to combine steps 1 and 2, and I'm going to write it directly as x equals 1/4 square root of y plus 3. Okay? So step 3, solve. Again, I'm going to switch my order just because it's easier for me to solve whatever I'm solving for on the left. And remembering I'm solving for y, so y now is not by itself, so I need to get it by itself. So I'm looking at the 1/4. I can see that's multiply. So a mathematically accurate thing to do would be divide both sides by 1/4. But then over here on the right side with x, that just does not look very nice. And obviously that's not simplified. So maybe I don't want to do that. So that's mathematically an all right thing to do, but solving wise, it's a little problematic. So I'm actually going to think about that. If I think about 1/4, 1/4, that's actually, if I say that as a full-on math statement, that's 1 divided by 4. So the inverse of division is multiply. So I probably want to actually just multiply by 4. And now when I look on the right side, that looks a little better to me. So 4/4 is 1. So that reduces to 1 right there. And then on the left, I'm going to be left with the square root of y plus 3. And on the right, I'm going to get 4x. Next step, I need to take the square root out because that is on the outside of everything. So that's next, okay? Because the 3 is inside. So what is the inverse of a square root? Is a square. So then what I have is y plus 3 equals, well, let's square that. I'm going to get 16x squared. And then the last thing I'm going to do is subtract the 3. And my last equation is y equals 16x squared minus 3. All right, and then last step, write it as an inverse. F inverse of x equals 16x squared minus 3. I will make one note here that when we did the square in this step, the square on this side happens to the entire side. So it's quantity of 4x squared. You do need your parentheses, okay? This is not 4x squared. That is not the same thing, all right? So be careful with your syntax. Add a lot of parentheses. Parentheses are your friends. All right, let's move on to number 4. Again, combining step 1 and 2, I'm going to get x equals 2 cube root of x minus 2. Sorry, I made a mistake. That should be y. So x equals 2 cube root of y minus 2 minus 4. Switching the order, 2 cube root of y minus 2 minus 4 equals x. And then remembering we're working outside to inside. So everything that's with y is here. Okay, multiplication, square root, whatever. So the thing that's not really attached is the minus 4. So adding the 4. 2 cube root of y minus 2 equals x plus 4. I see that I have a multiplication of 2 outside the radical. So then divide by the 2. Cube root of y minus 2 equals x plus 4 over 2. Now remove the cube to the third power. Okay. Y minus 2 equals x plus 4 over 2 quantity cubed. And then the last step would be adding the 2. So y equals quantity x plus 4 over 2 cubed plus 2. All right. So the x plus 4 cubed, let's look at a couple of options. X plus 4 over 2 quantity cubed, the entire thing cubed, could be x plus 4 to the third over 8. If you simplify inside, be careful because this 2 with the division needs to distribute like multiply, okay? So if you are distributing, you cannot just pick part of it to do and call it good, right? If you're doing it that way, what you actually get is x over 2 plus 2. And then I would want to see the whole thing cubed because otherwise you have to distribute everything. So that's what either I would choose for my format, either this one, the whole thing over 2 cubed, or this one, x plus 4 cubed over 8. Okay? Either one is fine. It's usually going to be easier if you just leave it sort of, try and just leave it unsimplified. So I'm just going to go with the first statement. F inverse of x equals parentheses x plus 4, that's a 4, 2 to the third plus 2. And then that is my solution. Okay? All right. The last two are the challenge problems. So 5 and 6 are the two hardest problems in here, essentially because we have x over x, all right, and a fraction bar. That means if I look at the fraction like 3/4, then the inverse of that is 4/3. So I can kind of think that this is multiplied by 3 divided by 4, which means my inverse is multiplied by 4 divided by 3. So if I start off with a fraction, I'm going to have to end with a fraction. So this one is definitely trickier. There's a bunch of stuff you have to do. Okay, let's start off with the first thing of switching the x and the y. So wait, I'm going to switch x and y direct. So let's see, I'm going to change that into x direct. X becomes y. All right, and then on this one, I'm not going to worry about switching the order, and essentially it's because the first thing I need to do, I cannot actually do anything with this in the fraction like this because I have a fraction and then I have plus and minus. So essentially right now I'm done, okay? So I need to somehow get it out of a fraction. So what I'm thinking is, oh, I know fraction is division, and maybe I even put in my parentheses, it's the quantity on top divided by the quantity on the bottom. And how I get rid of division is multiply. So what I'm going to do is multiply both sides by 5y minus 4. Okay, so what I now have is x times 5y minus 4 equals 2y plus 3, because why I did that is 5y minus 4 divided by 5y minus 4 is 1. And the other thing I did is just kind of switch this order, so because I can do that with multiply. Okay, like 5 times x is the same as x times 5. So I switched the order just because it's a little easier. Okay, I'm still having a little bit of an issue here because I now have parentheses. So the next thing I need to do is essentially distribute that x. So 5xy minus 4x equals 2y plus 3. All right. Now I'm going to remember that what I'm solving for is y. Because now I've got rid of all the things that might stop me from moving things around in my equation. So I want y alone. So the first step of solving, essentially, we could kind of think of this as a regular set now. What I want to get is everything with y on one side. So what I want to have is essentially, all the y values over here on one side of the equation, and then an equal sign and everything else. Okay, so the first thing I'm going to say is, okay, you know what? 5xy. That's already on the left. That's good to go. How would I move the 2y over? Well, I can subtract that. That moves the minus 2y to the left. But what do I have here? I see this minus 4x, and it shouldn't be there because it doesn't have a y term, okay? So what am I going to do to move it over is add it to both sides. So 3 plus 4x. So essentially the idea is that by adding and subtracting entire terms, I can reformat this. So my goal is to reformat this so everything with y is on one side of my equation and everything without y is on the other side. The reason I'm doing that now is this is the tricky part, okay? So the reason I'm doing that is because this is now, I now have a GCF of y because I'm trying to solve for y, all right? So what I need then is I'm going to pull y out as my GCF. There it is. And since it's a GCF, I factor it out, and inside is left 5x minus 2 equals, I'm just going to switch that so x is first. Okay. Now I got a multiplication problem. This is a times right here. So what I need to get rid of is this piece, and how I move it over is divide. Okay, so that reduces out to 1, and I'm pretty much completed. So what I look at then is I kind of say, do things look like they're opposite? Yes, they look division. I can kind of look at the top and compare it to the bottom. all right? But it's not a direct transfer because of the fact that it's basically a division problem, all right? So anyway, there I go. That's my answer. So my final inverse set, F inverse of x equals 4x plus 3 over 5x minus 2. Once again, you may want to try the next problem on your own before I solve it, because I'm just going to run through the solving. So pause right here if you would like to try it first. All right, the last problem. X equals y minus 2 over 4y minus 3. Sorry, plus 3. Thinking about this quantity on the top divided by the quantity on the bottom, what I need to do then is multiply both sides by 4y plus 3. So rewriting, I'm going to get x times 4y plus 3 equals y minus 2, because 4y plus 3 over 4y plus 3 reduced to 1. So next step, distribute the x. 4xy plus 3x equals y minus 2. Next thing, y needs to be all on the left. So the quantity 4xy is already on the left, so I just need to rewrite that. This y to move over, I subtract y from both sides. Okay. Then on the right, I need to move the quantity that's not got a y, that would be the 3x. I need it off of the left and onto the right. So I subtract 3x from both sides. So what I end up with is minus 3x minus 2. Right, now that I've done that, I'm now seeing that I have all my y terms on the left. So there's a y term with a y in it. There's the other y term. All of my y terms are on the left. So now that's a GCF. So I pull out that y value as a GCF, and then what's left is 4x minus 1. Be careful here because it just doesn't disappear, all right? If you have two terms, remember if you have two terms here and you pull out a GCF, you still have two terms to multiply, all right? What does that equal to? Negative 3x minus 2. Last step, divide out the 4x minus 1 on both sides. On the left, that reduces to 1, okay? And then my final answer, three x minus 2 over 4x minus 1. All right, depending if you did this yourself and you didn't get something exactly the same, make sure it's just not the order, but this would also be a valid answer. You could also get 3x plus 2 over negative 4x plus 1. Essentially, notice that all that's doing is moving the negative from the top to the bottom, which switches all your signs. So really this one sort of depends. The signs and where they end up sort of depends on which order you choose to do it in. But what I want you to remember is that if you have a positive number over a negative number, that's exactly the same as a negative over a positive. Essentially, they're both negative. Okay, so those are equivalent sets. All right, so that's what an inverse is and how you find one from a graph and from an equation. Have fun.